Hi everyone, welcome to a new video. In this lecture, we will go over some examples on how to use a Mongo query language MQL. So the first thing at this point, you should have your MongoDB is the extension available on your VS Code. So remember that you can use the Mongo shell if you want. I'm sorry for that, it's Mongo. There you go. And here you can use any database that is available. So at this point, you should also have installed uploaded the databases. There are some sample databases. The file, you will find it here online on our Brightspace. And with Mongo Restore, you will be able to load those databases. So over there, you will find sample Airbnb. It has a single collection. Now, since I can do the commands here, all the MQL here. However, since the nature of our course, it's more, related to analytics and data science, I prefer using the Jupyter Notebook. So we can use Python and we can use Pandas, for visualization. And if you want to create a model, so it's going to be easier, right? If we bring the queries to our notebook. So I'm going to exit the shell and I'm going to focus mainly on the Jupyter Notebook. All right. So the first thing is you need to load the PyMongo library. So this library will allow you to connect to the database. So for the connections, I'm using the local host. So we define the client, Mongo client, and typically you will use the same port, 27017. In some cases, if you're using in MongoDB, they have an online server. They call it Atlas, the online version. So if you have, for some reason you created the database online, so you can access right with your username and the password. That's not our case. All right. So in this case, our database was going to be sample Airbnb. It has some listings or some properties with information about, the amenities, the reviews, the location, everything that you can see on the website when you are exploring Airbnb options. The collection, there is just one, so it's listing and reviews. So in this specific database, we have more than 5,000 documents. You can explore them if you want. So for example, here, Airbnb. So in the documents, we can click view documents. So you can get an idea at least, of the different keys that they have: name, summary, space, description. Let's see, house rules, maximum nights, minimum nights, the review information, bedrooms, the number of people that accommodate, number of reviews, the amenities. So you have all that's for a single listing, right? But you have here more than 5,000 listings with all the information. Of course, it's each document is big because in some cases there are like 500 reviews for a single property. All right, so let's go back to our code. So let's see a couple of codes to go over and make some summaries about our DB, our database. So let's say that we want to count the total documents. So from that collection, we can use the command count documents, right? And we get the number of documents that we have available. We can explore one of them, right? Using the find one. This will find like a random document from our database, and we can print that specific document. This one is important. We can also extract the keys that are available for one specific document. You have to be careful here because remember that the MongoDB, here we have like flexibility in the schema. So it is possible that, like listings, they might have different keys. Not all of them, but maybe there is a key that is not, in one document, but it is available in other documents. So just be careful. You cannot base your analysis just on a single document to extract the keys, right? So we already know the number of documents in the collection. Here we get a sample document, right? And these are the keys for the random selected document, right? But you already know some of them because we explored the documents, right? You have to be careful here also because there are some nested keys, right? Let's say for ratings, for review scores, there are some like specific reviews, like like how clean was the apartment. So there are like 3 different scores, well, more than 3, I guess. Okay, so let's continue with some simple operations. So let's find, for example, the listings for a specific country. So let's say here in the US, United States. So from db dot the collection name, we find, and here in the find we can provide some filter alternatives. So our filter here is the address country equal to the US, United States, right? And then we have the projection here. The projection, it's an equivalent to select when you are using SQL. So it's pretty much which keys, in this case, or which fields you want to see, right? Because maybe you don't want to retrieve the, like all the complete information. You just want here the name, like the location, the price, and the number of bedrooms. So if you visualize it, you see the name, right? The price and number of bedrooms. I'm using a limit here because, of course, there are a lot of properties in the US. Okay, so here you get just 10 because we're limiting the output. So let's find listing with exactly 2 bedrooms. So there is a bedroom count here. That will be our limit equal to 2. So bedrooms 2, we're defining that here, and then the keys that we want to visualize in the output. So that's why we get the properties with exactly 2 rooms. Okay, so find listing with price less than 100. So in this case, we also use find. Find is very flexible. You see, we can add one condition or multiple conditions. So here for the price, the condition is it's less than, right? So we have here less than. Every time you see a dollar sign, typically it's for an operation. So the price here is 100. That's what we define. So less than 100, and the keys that we want to see for the documents. So when we explore them, some of them, so we see, of course, only properties with the price lower than 100. So let's see, for example, here, let's find luxury listings over $500 per night, and that can accommodate from 6 to 10 guests. And listings, this is another question. There are 3 questions here. Luxury listings over 500, then properties that can accommodate between 6 and 10 guests, and also these are 3 different questions, and listings with rating of 95 or higher. So let's see the first one, the luxury. So here the key is a price, it's greater than 500. So here you see all those properties with values, some of them almost close to the $1,000. In the case of the properties that can accommodate 6 to 10 guests, so here we have like an interval that includes the upper and lower bound, right? It includes the 6 and the 10. So that's why we have GTE greater than equal and lower than and equal, right? That's why we have the E. So the accommodates is the key, that's the name of the key. So between 6 and 10. So if you see the structure, it's similar, right, to what we have seen in the previous examples. And then projection, right, what we want to see. Now, if you notice in the Python code, in this code, I'm using some iterations here to visualize the properties, the documents. When you're using MongoDB directly, that there is no need to do that. It will show you everything, right? But when you're using Python, that's not the case. When you get the multiple documents, then you need to iterate to be able to visualize them. You can create also, in some cases, not always, but you can create data frames. That's another option. Okay, so let's find listing with review rating greater equal than 95. So here you just gotta be careful because the review rating, the review scores rating is a key that is inside another key. Let me show you in the document. When we're exploring documents, let's see. Okay, we have here amenities. We have a list of amenities. But let's find the ratings. There you go. Review scores. So inside review scores, as I mentioned earlier, there are multiple review scores for accuracy, cleanliness, checking, communication, location. This is the one that we want to get, review scores rating, right? So that's why we're using here like review scores rating to get access to that key that is nested. So you need to explore the documents in detail in order to know the exact names of the keys. But then everything is the same. So it's greater equal 95, right? And the field that you want to see. So you get the information, right? At this point, you get a sense that it's not difficult, especially now that you can use AI, but at least I want you to explore the syntax. So you get some familiarity with the code. It's not just copy and paste. I want you to get an idea and to understand what you're doing every time you see this MongoDB MQL code. I think it's straightforward. You can understand it and it's easy to follow in general. All right, so let's find listing with Wi-Fi. So that's part of the amenities, right? So in the amenities that it has Wi-Fi. So it gets the information. So let's find listing with both kitchen and free parking on premises. So here in the amenities, we use all. It means all of this list, right? It's like an OR. So we will find, and, it's like an and. So we'll have all of these. So it has kitchen and free parking on premises, right? It's gonna look for for properties or documents where in amenities we have these two. Same thing. You need to explore the names, like all possible parking alternatives before you start, like conducting your final query. You need to make sure that this is the right name, right, for the free parking, because there is also like free parking on street and things like that. So you need to ensure that you get the right one. Okay, so now we can count and we can find from the collection, amenities, all of them, and we can visualize them. Okay, so let's go. This is very important, the pipelines. So in the case of like more convoluted queries, some cases you will need to perform, like multiple operations. So in MongoDB, you have pipelines. You already know like the meaning of pipeline in data science, like when you have sequential steps, right? Like step 1, then step 2, and step 3. So here we can create pipelines with multiple steps. Typically, the steps will include to match, that's like filter, like define. We can group, we can project or select, right? We can sort and we can limit results. So there are, multiple alternatives here. So let's see some examples. In this one, we're going to match, we're going to project, which is like a select, and then we're going to sort. So this is the structure of the pipeline. It's just this one will have 3 operations. So match, project, sort. And there are 4 actually with the limit. So the first one, we're going to match the country to United States and number of bedrooms greater equal to 2 conditions. So that's the first step, right? Then we select with the project the name, the price, the bedrooms, and the suburb. Then we sort based on the price, and we limit to 10. So to run the pipeline, so first you define it, and then we can, using collection and aggregate the pipeline. So the aggregate is gonna run this pipeline. So we get the information with that. All right, let's see other examples. So here we have the average price by property type. That's what we want to visualize, right? Like for each, we want to group, right, by property and to compute the average price. So let's do that for properties with 2 or more bedrooms. So we match properties with 2 or more bedrooms. Then we group based on the property type, right? Because that's what we want to do. We find the average price. This is the we are applying here. When you see a dollar sign, you know that it's computing something. It's a function, right? And here is because we use dollar sign because we want to use the variable, right? Price, that key. Because if you remove the dollar sign, it's going to assume that this is a text. So just be careful with that. And it's going to count. It's going to add 1 every time it finds 1. All right. So at the end we sort. That's it. In this case, the -1 will do it from the greatest to the lowest value. All right. So we can visualize the properties. So here is like the most expensive properties. It's just one observation, right? But here, for example, we have house, and this is the average price, and the number of observations or listings that we're using to compute that value. So apartments, we have 1,000 observations, and the average price is 366. This is because we limited to greater or equal to. Let's do it with 1 if you want to increase, the number of listings analyzed here. So it's bigger, right? Now apartments, you have 3,000. So you get the idea of the pipeline. It's like a tidy way to organize your analysis and to perform several steps. So again, here we are matching, then we group, then we sort, and we limit. So we have 4 steps. Okay, so let's see one more, couple of them, 2 more. So let's see that we want to analyze the most common amenities in the apartment. Now, in the amenities, in each document, there are multiple amenities. So that's the meaning of this function here on wine. It's gonna retrieve that information. It's gonna split, the list of the amenities so we can manipulate them. So here with the on wine, what we do again is that we split, we extract the amenities, from the list, and then the next step is to group based on the amenities, right, on each value, and we're going to count them. We're going to sum to compute the frequencies, basically. Then we sort from the greatest to the smallest value, and here we're going to get the top 20. We visualize them, and of course, Wi-Fi is first, essentials, kitchen, TV, and you get the idea. So this is the last one. Let's say that we want to explore the rating distribution in our database. So we're creating a pipeline where we match. The first thing is we want to get the review scores that exist, right? Then we group based on the rating scores. For each of them, we compute the frequencies, that's the count here. And then we sort. So we can visualize, from the lowest rating to the greatest rating until the 100. So if you want, of course, you can visualize, and you see that in general they have high rating, right? There are some exceptions, as you can see here, but in general, it's from 80 and more, right? So in this sample, they have good ratings. Okay, so this was an overview of MQL in one specific example. The idea was just to cover the basics and also to show you the pipelines that are very useful to get some metrics, perform some analytics, and this combined with Python pandas that you already know, you can perform really nice analysis. Okay, that's everything in this video. I'll see you in our next lecture.